A circle has center 3, -2, and a radius of 5. Find the equation of the circle and sketch the circle. So these types of skills are relevant not only to circles but to parabolas, hyperbolas, exponential functions, linear functions. They're really similar style questions. So when asked to find the equation of the circle, you should immediately remember the distance formula, and we're going to use the distance formula between 2 points on a Cartesian plane to find out the equation of that circle. Let's go ahead and write down the distance formula in relation to circles. So let's go ahead and do that. So for part A, let me use my non-straight edge. The distance between the point and the center of a circle, so that point must be on the line itself for this to work, for the equation of a circle to be true. The point must be on the line of the circle, anywhere around that line. So the distance between that point and its center is equal to the square root of the x-coordinate of that point, take away the x-coordinate of the center, all squared, add the y-coordinate of that point, take away the the y-coordinate of its center squared. And that's square rooting all the entire terms here. All right, what we can do now is, now that we have the equation of a circle, we need to go ahead and make it the equation of this circle. So substituting the information that we know. We know the information about the coordinates of its center, and we know how big it is. We know the radius. So let's go ahead and plug those numbers in. Now remember, the distance between the point, any point around the circle on the circumference, to its center is the radius. And we know the radius is 5. So we'll go ahead and substitute PC for 5. And we know the center has a center of 3, -2. So we're going to substitute the x-coordinate of the center and the y-coordinate of the center with 3 and -2. Let's go ahead and do that all in one step. So 5 equals the square root of x. Now the x-coordinate of the point we don't know, so we'll just leave it as x. Take away the x-coordinate of our center, which we know is 3, squared. Add y, which we don't know yet, of our point. Take away the y-coordinate of our center, which is -2. So take away -2 will be +2 squared. Square root all of that. Now our last step is just to simplify, and we can simplify by removing this square root sign. And the way we would do that is by removing it and taking it to the other side of our equal sign, and instead of becoming square root, it will become squared. So it will be 5 squared, which is just 25. So 25 equals x minus 3 squared plus y plus 2 squared. So that's the equation of this particular circle. And for part B, we're going to try and sketch it. Let me go ahead and just reduce the size of all this working out so we have a bit more space. There we go. It's a little bit smaller now. All right, let's sketch the circle. Well, what information do we have in order to sketch the circle? Well, we have its center coordinate, and we know the radius is 5. So what we can do is we can go ahead and put this center on our graph here. So I've just got some grid for us to use. So let's go ahead and just put a center in. Let's just use this point here. Now that can be our center. We'll call that C, and it's got a coordinate of 3, -2. We know that to be true because it's part of the question. All right. Now that we know our center, we can figure out 4 points, north, south, east, and west, of this center to determine the shape and size of the circle. Because we know the radius is 5, we can just go up 5, left 5, right 5, and down 5, and just put some coordinates there and start forming a circle. So if we go up 5, we'll go all the way to 1, 2, 3, 4, 5. This position here, I just went up 5. And seeing as we went up, we're going up in the y-axis. -2, it's not going to be -2 anymore. It'll be -1, 0, 1, 2, 3. So the coordinate there will be 3, 3. All right, let's go left. So 1, 2, 3, 4, 5. we went backwards in the x-axis. So it'll be, instead of 3, -2, it'll be 2, -2, 1, -2, 0, -2, -1, -2, and -2, -2. So, -2, -2. All right, going down, let's go down. So down in the y-axis. So if we're at 3, -2 here, this will be 3, -3, 3, -4, 3, -5, 3, -6, 3, -7, right there. Going across to the right, let's do it. Now, if we're going across to the right, our x-axis is going up. So 3, -2, 4, -2, 5, -2, 6, -2, 7, -2, 8, -2, right there. That was 8, -2. Oh, and this coordinate here was, if we're going down, so 3, -2, 3, -3, 3, -4, 3, -5, 3, -6, 3, -7. 3, -7. Let's fill that in there. All right, so now we've got a picture of what our circle is going to look like. Let's go ahead and try and sketch that. Now, I'm not particularly concerned with how amazing your circle is. So what I'm going to go ahead and do is I'm going to draw a circle off to the side here, and I'll pick it up. And you won't be able to see this, but I'm just going to try and size it up so it fits over my circles. Now, you don't have that option as a student working with paper. But again, I'm not marking you on your ability to draw a perfect circle. Let's go ahead and just make that a little bit bigger. All right. As you can see, my line goes through each of the 4 points on my that I've plotted, going up, left, down, and right from the center. Okay. So I can use those 4 points to make the circle. That's what I expect you to be able to do. So with our center, now we'll go ahead and draw in the x-axis and the y-axis. So I'm going to use a black pen here, and let's try and figure out where the x-axis would be. This point right here, on the y-axis, we're at -2. And we know the x-axis cuts the y-axis at 0. So we just need to go up to 0. Here's -1, and here's 0. So my x-axis goes horizontally along this line here. So let's go ahead and do that. There's my x-axis. And let's go and figure out now where my y-axis would be. Well, my y-axis, if we start from our coordinate here, our y-axis cuts in when x is 0. If this is 3, if this coordinate right here is 3, well, this coordinate must be 2, this must be 1, and this must be 0. So our y-axis cuts the x-axis at 0. So it must be along this line here. So right there is my origin, and I can go ahead and label this. So let's put some arrows in to show that they are unlimited. Oops. Go. And this is x, this is -y, this is -x, and this is y. And we can start labeling. So here's 2. Oops, let's just go down. Here's 4. Here's 6. Here's 8. Let's go backwards. So here's 2 here. Let's go down. So -2, -4, -6. Let's go up. 2, and then here's 4 here. All right. So what we've done is we've labeled our circle with 4 coordinates and a center, and we've put in the x and y axis to show where it is relative to the x and y axis. All right, let's go ahead now and go to the next questions, part C. Determine whether the point 6, 2 is on the circle. So is 6, 2 on the circle? Well, we can use our sketch to determine that. Let's go across to 6 and 2. Is that point right there? Let's use green. is that point there on the circle? Well, it definitely is. 6, 2 is on the circle. So with my sketch, I can determine that. But what I'm looking for, what I expect to see is that you can determine this algebraically. Can you determine this without using the actual circle itself? That's what I'm looking for there. That's where the marks come from. Instead of using the circle itself, using algebra. So this is going to support your working out. We know now that 6, 2 is on the line. So what we'd expect is this. If we go ahead and substitute 6, 2, this coordinate here, if we go ahead and substitute this into our circle's equation, so putting the x coordinate here and the y coordinate here, if the left side becomes equal to the right side, we know then that that coordinate is on the line. If those two numbers are different, then it is not on the line. But as you can see, 6, 2 must be on the line, so we must get that the right-hand side must equal 25, or the left-hand side. Let's go ahead and do that. I'll do that in green. So part C, whoops. So part B we've already done. That was just to sketch the circle, so I've already done that. So part C, let's go ahead and work out whether 6, 2 is on the line. So here we go. Let's go ahead and write our circle's equation. So 5 equals x take 3. Oh, I apologize. Let's rewrite the proper one. 25, rather, equals x minus 3 squared plus y plus 2 squared. Now, we're going to substitute. We're going to substitute x for 6 and y for 2. Here we go. 25 equals, now x is 6, take 3 squared plus, and our y is now 2, plus 2 squared. Let's keep solving. So 6 minus 3 is 3. 3 squared is 9. So 9 plus 2 plus 2 is 4. 4 squared is 16. 25 equals 25. Our left-hand side is equal to our right-hand side. Therefore, 6, 2 is on the line. And we can do the same process for part D. Is negative 2 1 on the line? Let's have a look at our circle first. Is negative 2 1? Is that on the line? Let's use a different color. Let's go pink or purple. Is negative 2 1 on the line? Whoops, let's do that properly. Negative 2 1. Clearly, negative 2 1 is not on the line. So what we'd expect is that when we use, again, our circle's equation and substitute negative 2, 1 into this, the left-hand side will not be equal to the right-hand side. I'm predicting this. So let's go ahead and do that. It's our last question, and I'll do question D right here. All right, again, let's go ahead and write the equation of our circle. 25 equals x minus 3 squared plus y plus 2 squared. Now using the coordinates negative 2, 1, let's go ahead and substitute. So 25 equals negative 2 take 3 squared plus 1 plus 2 squared. I'm going to solve for the right hand side now. Let's do it. So negative 2 take 3 is negative 5. Negative 5 squared is 25. Now immediately you should be thinking, well, if we have to add anything to this, the answer to the right hand side must be 0. Like this must be 0 if the left hand side is going to be equal to the right hand side. We know that's not going to be the case though. So let's just go ahead and do this. 1 plus 2, that is 3. 3 squared is 9. 25 does not, put a line through the equal sign, does not equal 34. Therefore, the coordinate negative 2, 1 is not on the line because the left-hand side of this equation is not the same as the right-hand side when you substitute that coordinate.